Hello gents, today's lesson is on electricity production. We've spent a lot of time looking at how electricity works, so how charge flows through a system in terms of current, in terms of potential difference, etc. We haven't actually looked at how that potential difference, how that electricity is generated in the first place. So that's what today's lesson is going to be on. So let's go ahead and look at our lesson objectives. Okay, so our lesson objectives. We need to be able to explain the various sources of electricity production. So you have given a brief outline of how they all work. We also need to be able to give advantages and disadvantages of each of those different types of electricity production. And finally, we need to be able to distinguish between renewable and non-renewable resources. So let's just start by saying that electricity itself is not a source of energy. We need to generate that electricity somehow. So remember, one of the fundamental laws of physics, in fact I'd say the most fundamental law of physics, is the law of the conservation of energy. Energy cannot be created or destroyed, it can only be changed from one form to another. Now, electricity is a great way of us transferring energy from one place to another, but it is not in itself a source. Where do we get that electricity from in the first place? Where do we generate it from? And that's what we're going to be looking at today. Now, in most cases, we are going to use a generator to convert kinetic energy into electrical energy. And the diagram down at the bottom here shows a really basic generator. Now look, we are not going to go into the details of how these generators work. That is a year 11 topic, which we will cover in year 11 for those of you that carry on with the GCSE. But what I really care about is how we're generating that kinetic energy in the first place. How are we actually driving the generator that produces the electrical energy? So that's what we're going to concentrate rather than actually how a generator works. So how is that kinetic energy generated in the first place in order to drive those generators? Well, there are the three main ways are either using fossil fuels, nuclear energy or renewables. Now, both fossil fuels and renewables are very wide categories. They have lots of subcategories within them. And we're going to break those down and look at them one by one. So let's start by distinguishing between these renewable and non-renewable energy resources. So renewable, non-renewable. It's a really basic definition. Renewable energy resources are ones that are never ever going to run out. So they are inexhaustible. They are continually being replaced. They're continually being regenerated. And so no matter how much we use, it's always going to be there for us to use more. Whereas a non-renewable energy resource has a finite supply, i.e. one day we are going to run out of it. So a really basic difference between the two, a very, very important one that you really need to think about. Because at the end of the day, it's a really big advantage or a disadvantage as to whether something is renewable or not. If something is one day going to run out, that's obviously a massive disadvantage because eventually we're going to use it all and we can't use that form of energy production anymore. Whereas if it's renewable, it doesn't matter how much we use, we can continue to use it. So when we come to later on in the lesson talking about advantages and disadvantages, I always start with whether it's renewable or not, because obviously it's an advantage if it's renewable, massive disadvantage if it's not. Okay, just so you've got a rough idea of the split between those fossil fuels, nuclear and renewables, this is some information that I got from the UK for 2019. We can see here that fossil fuels make up 46% of the UK's electricity production. So a huge percentage in the UK. They often talk about in the news at the moment how they're not using as much coal, but they are still using quite a lot of gas in order to generate their electricity. So in terms of actually the amount of fossil fuels that are being burned in order to produce UK electricity, it's still actually quite high. Nuclear, as you can see, makes up 37% of our electricity production, quite a large percentage, and renewables just 17%, so disappointingly low. In Jersey, it's a slightly different picture. We import most of our electricity via underground cables from France, and so really, in order to be able to work out how much of our electricity is generated from each of our different categories, we need to look at France's data. I couldn't go back or get anything that was more recent than I could in the UK, so the most recent I could find that I could really rely on was back in 2016, and you can see here fossil fuels in France make up just 9%, so considerably lower in the UK. The UK very far behind France in terms of its electricity production. But it's not that they've got significantly more renewable. They haven't. I mean, I think the UK was only 17%. Here we've got 19%. It's the fact that France use a huge amount of nuclear energy, and therefore Jersey uses a huge amount of nuclear energy. So not that it's important, it's not important for your course, I just thought it was quite interesting to see where most of our electricity comes from. And in Jersey, most of it comes from nuclear. Okay, so let's look at the first of our three major types, that's fossil fuels. Now, fossil fuels consist primarily of coal, natural gas and oil. Now, for most of this lesson, I'll probably refer to natural gas as gas, but that's what I'm talking about, natural gas. Now, I think that one of the key things that we need to think about to start with is where these fossil fuels come from. And so that gives us our first activity for today's lesson. Okay, so for our first activity, I'd like you to pause the video and complete the fossil fuel card sort that has been sent to you on Show My Homework with this video. If you do have a printer, print it out and then stick your completed card sort into your book. If you haven't, you can do it on the Word document provided and then save it for a later date to be printed. Alternatively, if you do have access to a OneNote document that's been shared with you by your teacher, you can copy and paste it directly into that document and then that can be marked. So I think one of the most important things to take from the card sort you've just completed is the fact that fossil fuels take millions of years to be generated, to be created, and therefore we are using them up much faster than they are being produced. As a result, we are going to run out of them, and for that reason we categorize them as non-renewable energy resources. So in the case of both coal, gas and oil, all three are considered to be non-renewable. If you're ever in a situation where you're asked to give an advantage or a disadvantage of any energy resource, like I said earlier on, whether or not they're non-renewable or renewable has got to be one of your first options. And just remember that coal, gas and oil, all three are non-renewable. Okay, so one of our main fossil fuels was coal, and I want to take a look now at how that coal is used to generate electricity. And I found a really nice video on YouTube, which I'm going to show you now.
A series of conveyors transports the coal into the plant, where it passes through enormous pulverizers that grind the coal into a fine powder prior to burning. The pulverized coal is fed into a large industrial furnace that is surrounded by boiler tubes filled with water. The intense heat from the burning coal heats the water in the boiler tubes and turns it into steam. The steam is transferred under pressure at high speed through large pipes to turbines like these. It's this pressure and flow that pushes the blades of the turbine, causing it to spin. The turbine is connected to a generator.
From that video, we can see that the electrical energy being produced in a coal-fired power station is actually going through a series of energy changes. It's going from the chemical energy being stored in the coal, that is being burnt, producing thermal energy. And thermal energy is used to boil that water. The water then produces very high pressure steam, which is moved through pipes. As it's moving through those pipes under very high pressure, it turns huge turbines, and those turbines are then connected to the generators. A turbine, by the way, as you saw from that video, is just another name for effectively a big fan. So as the steam passes over the turbine, it causes that to spin, and the turbine itself is then connected to the generator, which is what takes that kinetic energy and produces the electrical energy. So we're going from chemical energy into thermal energy, into kinetic energy, and then finally into our electrical energy. This is a schematic. I'd really quite like you to get this into your notes. of just how the system works. So we've got coal being burnt in the furnace, turning that chemical energy into heat energy. And the first thing we want to note from here is that CO2 is being produced in that process. So lots of carbon locked up in those fossil fuels or in that coal. Think about the fact that when those plants were alive, they were absorbing CO2 from the atmosphere. That's then stored in that coal, and when we burn it, it's released. We're also getting lots of heat energy being released in that process, which is being used to boil the water to create that really high pressure steam. And that high pressure steam is then going to turn the turbine, effectively like I said, a big giant fan. And that turbine that's now spinning is connected to a generator, which produces the electricity itself. The steam then needs to be cooled down some way. And in the picture in the background, you can see the big cooling towers. That's what's going on, is it's cooling that steam down. And when it's been cooled down, it turns back into water, is pumped back into the furnace to then be reheated, to be turned back into steam, to then run over the turbine again. So it's a big circular process. I think that's quite a nice schematic that just kind of gives a rough idea of how the coal-fired power stations work. So we now know how a coal-fired power station works, but actually that's exactly the same as how a biofuel-powered power station or a nuclear energy plant also works. In both cases, the general principle of boiling water to generate steam, to turn a turbine, to turn a generator is exactly the same. The only difference between a coal-fired power station and these two other forms of energy production is what you're using to generate that thermal energy in the first place. So let's look at these two in a little bit more detail. So we'll start with nuclear fuels. We tend to use uranium or plutonium as the initial fuel source, which is a radioactive material, it undergoes a process of nuclear fission. Now, nuclear fission is the process of splitting atoms, and when you split those atoms, sorry, loads of energy is produced, a huge amount of energy is produced, and it's that thermal energy that is being released in the splitting of atoms that is then goes on to boil that water to produce the steam that turns the turbine. So like I say, the process is exactly the same. It's still just a big glorified kettle, but it just happens to be it's a kettle that's being heated by a nuclear reactor, and that is a fission reaction. So in the sun, you've got a fusion reaction, so that's when light elements are fused together to form heavier elements, and lots of energy is released in that process. But we're talking here about a nuclear fission event. So like I say, your heavy elements, that's things like uranium, plutonium, are being split into lighter elements. And in that process, lots of energy is being released. It's that energy that is being used to boil that water. So one of the first things we need to talk about nuclear is the fact that whether it is a renewable or non-renewable energy resource. Now, I've just said that it is using uranium and plutonium. There is only a finite supply of uranium and plutonium on Earth, and therefore we are going to run out of it. So it is therefore a non-renewable energy resource. We do have a finite supply of that fuel. However, the stock of that fuel, the amount on Earth, is far, far, far greater than the coal, the gas, and the oil. So it's going to last a lot longer. One of the big bonuses of the advantages of nuclear power stations is the fact they release absolutely no CO2 or NO2, so no carbon dioxide or nitrogen dioxide into the atmosphere. And don't get me wrong, there is waste, and that waste is incredibly radioactive. So when we split that uranium or that plutonium into smaller, lighter elements, those smaller, lighter elements are very, very radioactive. Now, they're not getting into the atmosphere, they're contained within the reactor. We can take them out, we can process them, we can keep them confined, but it is waste that we then have to deal with. How do they do that at the moment? Well, they dig a hole in the ground and they bury it. So one of the big disadvantages of nuclear power stations is the radioactive waste that is going to be the byproduct of that process. But which is better, releasing that CO2 into the atmosphere, causing global warming, or having this radioactive fuel that we can process and contain relatively, not easily, but far better than we can with the carbon dioxide that's being produced, or the nitrogen dioxide that's being produced in fossil fuel powered power stations. So we've looked at how coal and nuclear energy is used to boil water to generate that steam to turn that turbine. But we can also use what we call biofuels. Now, biofuels are any material, any organic material that can be burnt to create that initial heat source that is used to boil that water. Now, let's look at some examples of the kind of things that we would consider to be biofuels. So the kind of things that we're looking at are things like wood and other plant materials, so straw, nutshells, wood chips, animal waste, so literal animal feces. Some great examples of the zoos using the waste from animals to actually generate electricity by burning it. You've got things like biodiesel, so there's a lot of people that actually used cooking fat from restaurants and things like that, actually reprocess it to create a kind of fuel they can actually put in their cars. That can also be burnt to generate electricity. Things like ethanol, so fermented plant material. Ethanol is effectively alcohol. So if you actually ferment, if you put the right kind of yeasts into certain substances, it can actually turn it into alcohol. That alcohol can then be burnt. And finally, methane, so it's very similar. You're using certain types of bacteria to eat the waste, whether it be plant or feces. Those bacteria, as they eat that biological material, actually produce lots of methane gas. And that gas can then be burnt off, which then obviously produces the heat, which can boil the water, which generates the steam, which then turns the turbine and which turns the generator. So all of these are considered to be biofuels. Are these renewable or non-renewable? Well, biofuels are definitely renewable energy resources because we can just grow new plants. Animals are going to be producing feces all the time. It's never going to run out. We're always going to be able to plant new trees, we're going to have to plant new crops to be able to burn them. So one of the big advantages of biofuels over some of the other types of energy is the fact that they are renewable. We can just keep growing them. Okay, so I want to look at a slightly different type of energy production now, and that's using gas. So with gas-fired power stations, we are still using a fossil fuel, so definitely a disadvantage of a gas-fired power station is going to be the fact that we're using a non-renewable fossil fuel. That is going to be releasing CO2, not as much as the coal, but it's definitely going to be releasing CO2 into the atmosphere. It's also going to be producing a lot of nitrogen dioxide, which leads to things like acid rain. Not very good for crops. Obviously, if it's raining, and that's going to increase the acidity of the soil, certain crops and plants are not going to be able to grow so well in that, which can have quite significant effects on wildlife, etc. In certain regions. But look, let's have a look at how gas-fired power stations work. Again, I found a really nice video to show it.
Here's a simple little version I've built here. What's at the front of a gas turbine is a compressor. The job of the compressor is to suck air into here, the combustion chamber. There, highly flammable gas is injected in. I'm using propane. This goes in scientifically measured quantities. Then the gas-air mixture is ignited. I'll wear goggles for this stage. Oof. Excellent. Now, once that mixture is ignited, it heats up and expands rapidly. The expansion drives through this turbine at the back. That's then rapidly rotated. That turns a little generator, which produces electricity for our towns and cities. So all it takes to produce more electricity is more gas, which can be done with the twiddle of a knob, even on an industrial scale.
Okay, so we've now seen how coal, biofuels, nuclear and gas are all used to generate electricity. What I want you to do now is to pause the video. It's our second activity. I want you to list as many other non-renewable forms of energy as you can. So far in our list, we've only actually really got the one, that's biofuels. All the others we've looked at are non-renewable. I want you to list out as many more renewables as you can, please. Okay, so this is the list that I produced. The ones we're going to look at in a little bit more detail are hydroelectric power stations, some kind of solar. There's different types of solar. We're going to look at least 2 different types. We're going to look at wind generators, geothermal, and then here I could have separated them or put them together. I've decided to put them together here. I've got tidal and wave power. So we've got 5 different forms of energy production that we're going to look at. I've found a series of videos for us to be able to do that. So like I say, we're going to look at a series of videos to see how these different renewable energy resources are used. But our next activity is going to be to list the advantages and disadvantages of each of these different types of energy production. So whilst you're watching, it might be worth just making a few notes if there are any kind of comments on the advantages and disadvantages, or if you think of any yourself whilst you're watching them, just note them down, because it's going to make your job, your life a little bit easier when you come to doing the next activity.
Hydropower. Hydropower, or hydroelectricity, refers to the conversion of energy from flowing water into electricity. It is considered a renewable energy source because the water cycle is constantly renewed by the sun. One of the first uses of hydroenergy was for mechanical milling, such as grinding grains. But today, modern hydro plants produce electricity using turbines and generators. The mechanical energy created by moving water spins rotors on a turbine. This turbine is connected to an electromagnetic generator, which produces electricity when the turbine spins. There are 2 main types of hydroelectricity production: dams and run-of-river. Hydro dams utilize the potential energy from dammed water to produce electricity. A dam is a large barrier constructed to raise the level of water and control its flow. The elevation created by the dam creates gravitational force for turning the turbine when water is released. Some dams also contain an additional reservoir at their base where water is stored to be pumped to the higher reservoir for release when electricity is in demand. This is referred to as pumped storage hydro. The second form of hydroelectricity production is run-of-river hydro. Run-of-river still uses turbines and generators, but relies on natural water flow rates of rivers, diverting just a portion of the water through turbines. Because run-of-river hydro is subject to natural water variability, it is more intermittent than dammed hydro.
Solar power is the most abundant, most renewable resource we have. If we could collect 1/100th of 1% of the sun's energy reaching the earth, it would be more energy than all humans use today. There are 2 ways of capturing the power of the sun. First is photovoltaic devices, more commonly known as solar cells. They change sunlight directly into electricity. These individual cells are joined together to make solar panels. These can be placed on rooftops, in calculators, and even on large-scale fields covering many acres to power cities. Solar energy systems produce no air pollutants or carbon dioxide. And because they can be placed on the top of existing buildings, they do not require extra land for power plants. Another way to capture the sun's energy is by capturing its heat. Solar thermal electric power plants generate electricity by concentrating solar energy to boil water, which then produces steam. This steam turns a turbine, which moves a generator to produce electricity. Solar thermal electric plants consist of fields of mirrors to reflect the concentrated sunlight onto a receiver. The receiver then collects the solar energy and converts it to heat. The production of energy from solar thermal plants work essentially the same as fossil fuel power plants. But instead of producing steam from burning fossil fuels, the steam is made by the sun. The only downside to this source of technology is that the power only exists as long as the sun is up.
We've all seen those creaky old windmills on farms, and although they may seem about as low-tech as you can get, those old windmills are the predecessors for new modern wind turbines that generate electricity. The The same wind that used to pump water for cattle is now turning giant wind turbines to power cities and homes. Okay, have a look at this wind farm in the California desert. A hot desert next to tall mountains, an ideal place for a lot of wind. Here's another one on the windy prairies of Wyoming. Now, today's wind turbines are much more complicated machines than the old prairie windmills, but the principle is the same. Both capture the wind's energy. Okay, here's how it works. First, a wind turbine blade works sort of like an airplane wing. Blowing air passes around both sides of the blade. The shape of the blade causes the air pressure to be uneven, higher on one side of the blade and lower on the other. And that's what makes it spin. The uneven pressure causes the blades to spin around the center of the turbine. On the top, there's a weather vane that's connected to a computer to keep the turbine turned into the wind so it captures the most energy. Now, the blades are attached to a shaft, which only turns about 18 revolutions a minute, and that's not nearly fast enough to generate electricity by itself. So, the rotor shaft spins a series of gears that increase the rotation up to about 1,800 revolutions per minute. And at that speed, the generator can produce a lot of electricity. So, why are wind turbines so tall? Well, the higher up you go, the windier it is. More wind naturally means more electricity. And in many cases, larger turbines can also capture wind energy more efficiently. The blades can sweep a circle in the sky as long as a football field. Now, what's really cool is that even a small wind farm, like this one in Wyoming, can generate enough electricity to power more than 9,000 homes. And larger farms can provide much more clean energy for our homes and businesses.
Renewable Energy 101. If you've ever observed an erupting volcano or the geysers at Yellowstone National Park, you've seen geothermal energy in action. The Earth's crust is made of rocks and water. Deep below that is a layer of hot, molten rock called magma, which is even hotter than the sun's surface. The heat just over 6 miles below the surface contains 50,000 times more energy than all the oil and natural gas resources in the world. Releasing a small amount of that heat in the right way can create electricity. A well drilled a couple of miles deep can capture the rising hot water and steam. That steam spins a turbine and a generator produces electricity. Geothermal is one of the least explored sources of renewable energy in the US, and most of us probably don't spend much time thinking about it. But since it's a pollution-free, renewable source of energy that's consistently reliable, at least it has been for the past 4.5 billion years, maybe we should.
Tidal power. Tidal power is a form of hydropower that converts the energy from the natural rise and fall of the tides into electricity. Tides are caused by the combined effects of gravitational forces exerted by the moon, the sun, and the rotation of the earth. Tidal plants can only be installed along coastlines. Coastlines often experience 2 high tides and 2 low tides on a daily basis. The difference in water levels must be at least 5 meters high to produce electricity. Tidal electricity can be created from several technologies, the main ones being tidal barrages, tidal fences, and tidal turbines. Tidal barrages are the most efficient tidal energy sources. A tidal barrage is a dam that utilizes the potential energy generated by the change in height between high and low tides. This energy turns a turbine or compresses air, which in turn creates electricity. Tidal fences are turbines that operate like giant turnstiles, whereas tidal turbines are similar to wind turbines, only underwater. In both cases, electricity is generated when the mechanical energy of tidal currents turns turbines connected to a generator. The generator produces electricity. Ocean currents generate relatively more energy than air currents because ocean water is 832 times more dense than air and therefore applies greater force on the turbines. Tidal power is easy to install and renewable, having no direct greenhouse gas emissions and a low environmental impact. Because the ocean's tidal patterns are well understood, tidal energy is a very predictable energy source, making it highly attractive for electrical grid management. This sets it apart from other renewables that can be more unpredictable. However, adoption of tidal technologies has been slow, and so far the amount of power generated using tidal power plants is very small. This is due largely to the very specific site requirements necessary to produce tidal electricity. Additionally, tide cycles do not always match the daily consumption patterns of electricity and therefore do not provide sufficient capacity to satisfy demand. That's tidal power.
The operating principle of this wave power station is as simple as it is ingenious. An enclosed chamber has an opening beneath sea level, which allows water to flow from the sea to the chamber and back. The water level in the chamber rises and falls with the rhythm of the waves, and air is forced forwards and backwards through the turbine, connected to an upper opening in the chamber. As it is compressed and decompressed, the airflow has sufficient power to drive the Wells turbine. It is a feature of the Wells turbine, named after its inventor, that it is driven in the same direction by both forward and reverse airflow through the turbine. Even relatively low wave motions can generate enough airflow to keep the turbine moving and to generate energy. This is how easily energy can be generated with a wave power station, day and night, all year round, as long as there are waves.
So we've now seen how all of our different forms of energy production operate, how they work. One of the next key things for us to understand is what the advantages and disadvantages of those processes are. So our next activity is for you to pause the video again, and using the sheet that was sent to you on Show My Homework with this video is to list out the advantages and disadvantages of each form of electricity production. We've already covered quite a lot. So in the videos that we've seen, in what we've discussed, but you might want to just kind of do a quick Google search, maybe have a look on BBC Bite Size, see if you can find any advantages and disadvantages of each. Don't spend too long on it, but just maybe spend 5 or 10 minutes just kind of listing out the advantages and disadvantages of each of those different types of energy production. So by now you should have quite a comprehensive list of advantages and disadvantages of each form of energy production that we've discussed in the lesson so far. If you haven't, please do pause the video, go back and produce that list before moving forward. If you do have it, what I now want to do is to go through my list of advantages and disadvantages so that we can compare the two and make sure that your list is the same as mine. Now, I might not have every single advantages and disadvantages that you have found, and don't worry, it's not to say that it's wrong, it's just that I've produced the kind of the core list, the things that I think are very, very important that you should definitely have in your list. And therefore, if you have got something missing, so I've got something in my list that isn't in yours, please do add it in at this stage. So we're going to start with coal. I think one of the key ones with coal is the reliability of coal. So if a power station wants to be producing 5 gigawatts at Sunday at 2 o'clock, it will produce 5 gigawatts at Sunday at 2 o'clock, because it doesn't rely on anything other than having that coal. And because coal is so easily sourced, it is something that that you can kind of produce on demand. Now, obviously, one of the disadvantages is the fact that it's a non-renewable energy resource, so we are going to run out of it. But at the moment, we can get it relatively easily. So going on to those disadvantages, the first one I've already mentioned, that's a non-renewable energy resource, and it's the second one that I think for me is core. And certainly if I was asked this in an exam, this is the one that I'd always give, but lots of CO2 is produced when burning coal. Now that obviously has been linked to global warming and is having pretty detrimental effects on the planet. And so the production of that CO2 and the release of that CO2 during the burning of coal is a massive disadvantage for coal-fired power stations. Finally, I've got down here that they are very slow to respond to changes in demand. So yes, a power station can decide that at 2 o'clock on a Sunday it's going to produce those 5 gigawatts. But if all of a sudden there's a massive spike in demand, because of the fact that we have to boil quite a lot of water in order to produce that steam to turn the turbine, we can't just turn up that power station and expect to get more electricity being generated instantly. It takes time for that more water to be boiled, for that steam to be generated, and so it's very, very slow to respond to those changes in demand. So moving on to gas. Like with coal, gas is an incredibly reliable form of energy production. We can generate exactly how much we want when we want. To add to that, because no water needs to be boiled, it is very quick to changes in demand. So if at half time during the World Cup final, everyone goes and puts the kettle on, there's a massive spike in demand, and the coal-fired power station can just start pumping more gas into the combustion chamber, which then kind of ramps up the amount of electricity that's being generated. We're not boiling water, and so we don't need to kind of wait for that water to be heated like we do with the coal-fired power station. So, like I say, much quicker to changes in demand, which is definitely an advantage. Again, with coal, or again in the same way as coal, gas is very easily sourced at the moment. Disadvantages, again, it's non-renewable, so even though we can get it easily now, in the long run, in the future, we are definitely going to run out of it. The second one, again, I think is probably the most important one for me. We're producing CO2 and NO2. Now, we're not producing as much carbon dioxide, we're not producing as much of that CO2 as we are with coal, but we are producing a lot of the nitrogen dioxide. Nitrogen dioxide is the cause of acid rain, and that has a really detrimental effect on the acidity of soil, which can then affect the plant life that is growing in that soil, which can therefore have knock-on effects for the rest of the ecosystem that's being affected. So big disadvantage there for gas-fired power stations. Okay, so on to nuclear. The biggest advantage for me is the fact that absolutely no greenhouse gases, so no CO2, no NO2 are being released at all in the process. Secondly, the supply of nuclear fuel is incredibly stable. We get most of our uranium from Australia, so a very politically stable region of the world. So the price and the supply, very stable. In terms of the disadvantages, it's a non-renewable energy resource, so we are going to run out of it one day. Like I said earlier on, it is a lot further down the line than it is with other forms of fossil fuels, but it is going to be depleted eventually. Secondly, nuclear power stations are incredibly expensive to commission, to build them and to run them, and also incredibly expensive to shut them down. Effectively, the actual core where the nuclear reaction takes place is so radioactive that it can never really be dismantled, so it just has to stay where it is. With a coal-fired power station or a gas-fired power station, if you decide to knock that power station down, within a few years you'd never know it was there, whereas with a nuclear power station, that effectively has to stay there for the duration of our lifetimes. The other thing to talk about is the waste that's being produced in a radioactive power station. That waste is very radioactive and will be for a very long period of time. As I said earlier on, the only thing we can do with it at the moment is just to bury it, which is what we are doing. Next is the potential risk for nuclear accidents. Here's a good time to talk about things like Chernobyl or Fukushima. Two very famous nuclear accidents that resulted in large areas of land being contaminated with radioactive material, which then has kind of far-reaching effects on both the health of people and wildlife. Finally, just want to mention the fact that nuclear power stations are incredibly slow to respond to changes in demand. So like with coal and biofuels, you need to boil water, and the amount of energy that's being released in that core, and hence boiling that water, you can't just ramp it up very suddenly or slow it down. Actually, you turn it on and it's just running, and it is going to be producing a very stable level of or amount of electricity at any given time. So moving on to the renewables, we're going to start with biofuels. And the first advantage, obviously, is that it's renewable, but secondly, it's considered to be carbon neutral. Now, I put almost here because it isn't entirely carbon neutral. The argument being is, yes, the amount of carbon removed from the atmosphere by those plants is equal to the amount of carbon released when they're burnt, But what about the carbon that is released by, say, for example, the combine harvester that is being used to actually harvest that crop? What about the lorries and the trucks that are used to transport those crops from the farm to the power plant? If you add that in as well, then all of a sudden they're not entirely carbon neutral. Moving on to the disadvantages, I think the big one for me is the fact that the land being used to grow those crops can't be used to grow food, and therefore, if you're in a country that relies heavily on localized food production, then it could cause food shortages, which obviously has dire effect on the local populace. Secondly, like with coal and nuclear, it is very slow to respond to changes in demand because we have to boil this water. Wind turbines, advantages, obviously renewable, and also requires no external fuel, so it has a low running cost. We do need to be careful here. A lot of people say, oh, wind turbines are free. They're free to run, but they are very expensive to build in the first place, and they also have moving parts, and so they are can be costly to maintain, especially ones that are out at sea. Obviously, getting access to them is quite difficult, and so you've got to have a kind of a permanent crew that are on board ships going out to the North Sea, which is where most of ours are in the UK, to maintain them. The other things to think about, the fact that they aren't reliable, and we've talked a lot about reliability so far, with our advantages and disadvantages, and wind turbines definitely are not reliable because it's not always windy. So on very still days, we're not going to get lots of electricity being generated by wind turbines. And finally, the other thing is looking at those kind of the effects into the visual and noise pollution. A lot of people think they're very ugly. I don't. I actually think they're very majestic. I really like the look of them, but a lot of people wouldn't want one at the bottom of their garden. And actually they are very, very noisy. I think people underestimate just how loud they are. So visual and noise pollution is definitely a significant disadvantage. Okay, on to solar cells. Again, renewable. Also have no external fuel, and so have a very low running cost. They also don't require much maintenance. I mean, you need to wipe the surface down every now and then, but because we've got no moving parts that are going to rub against each other with friction, you're not going to have any significant maintenance costs. So once they've been installed, actually, they're very, very, very cheap to run. However, they are very expensive to actually build in the first place. The kind of solar array that you might have on the top of your house, probably talking in the region of about £20,000 to £30,000 to be able to install one of those things. So yes, they are free once you've installed them, but very expensive to build in the first place. Going back to reliability, obviously it's not always sunny. In the winter, you're talking about most of the day being in darkness, 17 hours of the day being in darkness, and so it's not going to be producing any electricity at those times. And even in the middle of the day, if it's very overcast, they're not going to be running at optimum efficiency. So really only good in places that have got lots and lots of sunlight. The other thing is the visual pollution. A lot of people think they're very ugly, don't want them stuck on the top of their houses. So moving on to hydroelectric power stations, obviously major advantage is the fact that it's renewable. Also, the amount of electricity being generated can be very easily controlled. It's really reliable. It's also very quick to respond to changes in demand. If we have a spike in demand, we can just open up the valve, allow more water to pass through our pipes to turn those turbines, and so we can increase the amount of electricity being generated. The other great advantage is we've got no CO2, no NO2 being released in the process, and it requires no external fuel, so we're not having to bring fuel into the power station. So the running costs are relatively low. However, very, very high build costs. To build those dams in the first place are very, very expensive. We also need to think about the fact they can only be installed in certain locations. You can't just put them anywhere. And the other thing to think about is when you're creating those huge reservoirs of water behind those dams, you're filling those valleys with water, and therefore you're going to kill a lot of wildlife and kind of affect huge amounts of wildlife. Okay, geothermal, obviously again it's renewable. The amount of electricity being generated can be easily controlled, and again no pollution created, no external fuel sources, all really good advantages. Disadvantages: also can only be used in certain locations. We need somewhere where the Earth's crust is thin enough for us to be able to actually get down, but also depends what the Earth's crust is made of. You know, if you're in a region like Jersey where it's granite, it's going to be very difficult to drill through it in order to get down deep enough in order to be able to make anything useful. So effectively it kind of rules out using geothermal in Jersey. You need somewhere where you can drill into the land relatively easily, and you don't have to drill down that far in order to be able to get to hot enough regions to be able to heat that water up. Very, very high installation costs, and also does pose potential hazards. People aren't particularly happy. Think about things like fracking and the upset that causes, and well, you know, it's very similar here. You're going to be drilling down into tectonic plates. People aren't necessarily going to be particularly very happy about that. Okay, tidal. I've actually split tidal and wave up here, but tidal, the advantages: it's renewable, obviously no pollution, no CO2, no NO2, requires no external fuel. The other thing about tidal is it's very predictable. You know, you can look at tide tables to find out what the tide is going to be doing in years in the future. So we know exactly when we're going to have peak production, when we're going to have very little production, because we can look at exactly what the tide is going to be doing over very long periods of time. Disadvantages: again, only available in certain locations. It couldn't be used everywhere. Very high installation and maintenance cost of these things. And also, lots of people argue there's quite a potential hazard to marine life. So if you're going to go and put huge fans in, so huge turbines in the ocean, you know, what effect is that going to have on fish and other marine species? And finally, onto waves. So with the advantages: it's renewable, no pollution created, and requires no external fuel. Disadvantages: it is not reliable. There's not always going to be waves, and therefore we can't always kind of completely rely on it. We're going to have some kind of backup that kicks in when we've got a very calm, still day. Again, like with the tidal, it can only be used in certain locations. Has very, very high maintenance costs, and also produces or causes potential hazards to marine life. So very similar to the tidal, but just got this added disadvantage of not being particularly very reliable. Okay, just to summarize what we've done today then. So you should have a basic understanding of how each of these different methods of electricity production works. You do not need to go into detail. You just need to have a rough idea of how that electricity is generated. Secondly, you should be able to give advantages and disadvantages of each form of electricity production. The key ones to always mention are reliability and pollution, and also whether it's renewable or non-renewable. And therefore, the last thing we wanted you to be able to do at the end of this lesson was to be able to distinguish between renewable and non-renewable energy resources. Okay, and finally, for anyone that is interested in doing a little bit extra, we've got 4 research tasks here. You don't have to do them, they're totally voluntary, but all 4 are very, very close to home.